So this example is quite similar to the last one, but with one added piece of complexity. In this one, we do not know which of the two reactants we're talking about is the limiting reagent. So we need to treat this as a limiting reagent question before dealing with the percentage yield. What we know is that we get hydrogen in this industrial process by reacting methane, which is CH4, with water vapor, H2O. We know that we have taken 1.61 grams of methane and combined it with 2 grams of water, and in actual we have produced 0.50 grams of hydrogen. As with the last example, what we actually produce does not come into play yet until we know how much we should have made in theory. And that's what we need to do right now. First, to find the theoretical yield, we need to determine which is the limiting reagent. So to do that, we need to deal with how many moles of both methane and water we used. So I'm just going to go to a clean page because this is going to be a little bit longer. What we know is that we have some moles of methane and we also know that we have some moles of water. The first step we need to take is determine exactly how many moles of each. So for the methane, we need its molar mass. Methane is made up of a single carbon, which weighs 12.011 grams per mole. 4 hydrogens, which would be 4 times 1.008, which would total to 4.032. Adding that up gives us a molar mass for CH4 of 16.043 grams per mole. And now that we know the molar mass, we can calculate the number of moles. Again, going to the mole conversion chart, it's mass divided by molar mass. We have 1.61 grams of CH4. Molar mass is 16.043. Gives us 0.10036 moles of CH4. And I'm just going to put this up top so we have everything in one spot. Same process for the water. We need the molar mass of water, made up of 2 hydrogens. Mass of each hydrogen, 1.008, totals to 2.016. Single oxygen, which weighs 15.999 grams per mole, and that totals up to 18.015 grams per mole for water. The number of moles of water, we take the mass, 2.00 grams, divide by the molar mass of 18.015. Tells us that we have 0.11102 moles of water. So now at this point, we need to make an assumption that one or the other of these is the limiting reagent. And as always, it doesn't matter. I'm going to pick methane just because it came first. So if we assume that methane is the limiting reagent, we can determine how much water we would need to use up all of the methane. Simple mole ratio calculation. So we have 0.10036 moles of methane. Looking at the question, mole ratios for methane and water. Methane is 1, water is also 1. So we'll multiply by 1 mole of water over 1 mole of methane. Makes the calculation a little bit easier when it's a 1-to-1 mole ratio. This would mean that we would need 0.10036 moles of water. And we just saw on the last slide that we have 0.11102 moles of water. So we have 0.11102, we need 0.10036, so we have more than enough water. So water is the excess reagent, so therefore methane is the limiting reagent. We were correct in the assumption. Now that we know this, we can go and we can find the theoretical yield of hydrogen. So this would be step 2 of the stoichiometry. We need how many moles of hydrogen we would make with that much methane. We know we're going to use up 0.10036 moles of methane. Looking at the chemical equation for the mole ratios, we have 3 moles of hydrogen in the chemical equation, 1 mole of methane. Multiplying that out gives us 0.30108 moles of hydrogen, and this is how much we should make in theory. Now that we know the number of moles we should make of hydrogen in theory, we can figure out the mass of hydrogen, again, in theory. To do that, we need the molar mass. Not overly difficult, but not the most simple. We have 2 hydrogens, each hydrogen weighing 1.008 grams per mole. That works out to 2.016 grams per mole for the molar mass of hydrogen. The mass, again going to the mole conversion chart, the mass equals the number of moles multiplied by the molar mass. So we get 0.30108 moles times a molar mass of 2.016 grams per mole. Tells us that we should have made 0.607 grams of hydrogen in theory. We should have. Knowing this, now we can find the percent yield, which is the actual amount of hydrogen that was made, divided by the theoretical, times 100%. In the question, we put this off in green. We actually made 0.50 grams of hydrogen. In theory, we should have made 0.607 grams. Working that out, and we will need 2 sig figs because the 0.50 grams of hydrogen gives us a percentage yield of 82%.